Good morning, everyone. It's really great to be here. I'm really delighted to come and to speak to you all about soil. It's kind of one of the passions of my life. Somebody just asked me how long have I been into soil. Well, many years now, probably. Yeah, I think I started studying in the mid-1980s. So I hope I can pass on a bit of that enthusiasm to you this morning. So it's that stuff beneath your feet that we're going to talk about. And I want really... This morning, I guess what I want you to take away from this talk are three things. One is that soil really does have value, that not all soils are alike. It's not all clay beneath our feet, as much as you might think it is if you live in Stoke-on-Trent. And also this loss of soil to landfill is an absolute scandal. And I was really pleased to see those numbers in Claire's talk earlier. So we all know about, most of our food comes from soil. We grow our crops in soil. Animals feed on some of those crops as well. So we all know about that as a key fundamental for life on the planet. But you might be less aware that soil is also this kind of living entity, and within that soil there is a vast amount of life. And there's a recent estimate that almost 60% of life on this planet, or the biodiversity on the planet, is associated with soil. And that ranges from, I don't know if we got a little laser pointer on here, from the really tiny stuff like bacteria, up through little arthropods, right up to worms, and then you could go to mammals that are feeding on those worms, the moles that leave those lumps in your garden perhaps, and then the plants that grow in the soil. So there's this vast amount of life which depends upon soil. It's also a really huge store of carbon as well. And these are just some numbers for the UK. So around about 10 billion tonnes of carbon are in the soil. So that's I did my maths, I hope I got it right. But around about 150 tonnes for every one of you in this room. So that's quite a lot of carbon if you start to then compare that to the per capita emissions, which for kilograms of carbon are around about 1.2 tonnes for each of us in this room, which is also quite a startling number, I think. But it just gives you a scale of just how much carbon there is in soil. And half of this is in peat. So if you go up to the top of the Pennines, or you go to Scotland, or some of the other lowland areas like the Fens, where you've got these beautiful, dark, almost black soils, which are highly organic, they're storing most of our carbon in soils, and that's why it's so important that we're trying to protect those. And it was great to hear about some wetland restoration projects earlier this morning. And that carbon in soil is bigger than all the carbon in all the vegetation and the atmosphere combined. So it is generally a global store, and that's why soil scientists and others around the world at the moment are getting quite, tied up with this and trying to find ways of building those carbon contents or rebuilding those carbon contents in soils, because it's such a big store, and so it can have an impact on the atmosphere. The other thing that soils are really important for is how they deal with water as well. And this was a photo I took just a couple of weeks back when I was up in Cumbria doing a little bit of field work. And we can sometimes have too much water in soil, and it starts to pour over the soil surface and can then cause flooding. And this soil was absolutely sodden to the surface, and there wasn't really anywhere for the water to go apart from over the soil surface. So soils and how we manage them can link to flooding, which obviously then has economic and social impacts. But we can also have too little as well, and many of you, I guess, if you're from the south or the east of England, that this year will have experienced drought. You will have seen the effects of drought, and soils can help to mitigate those drought effects by storing water for use throughout the year. So if you imagine your soil profile, it's got lots of water within it, and these plants are extracting it. If you can get more water into the soil that's going to be stored there, that extraction of water can also have the impact of cooling the climate as well. So you can actually have positive or negative effects on the drought. So you can actually cool down the system and so start to have some mitigation effects as well. So from that perspective, soils are really key. And obviously, if you're a commercial grower like this one, you want to have enough water because you want to produce the crop that's going to generate you some income and is going to generate some food for people as well. And then I thought, well, I'm at a ceramics meeting. I probably should mention soils and ceramics as well. And I suppose my interaction with this really came, I suppose, through two things. One was seeing people in Kenya building bricks, and I looked high and low to find my own photographs of people doing this, and I struggled and I couldn't find them, so I had to steal somebody else's. But amazing people forming bricks and then firing them in kilns made out of those bricks, which was just amazing to see. And those are, really just very shallow pits that people were extracting soil from. And then, perhaps I think, and you probably know this way better than I do, but one of the oldest bits of ceramic in the world is the Venus of Dolny Vestanici, I think, which I didn't see that one, but I went to a museum in Austria and saw a very similar Venus, which had been extracted or made from the local soil, the Lurs soil, which this Venus was also made from, and then fired locally. So a really early example of ceramics, and I think possibly the oldest in the world. So soil has that amazing value for all our lives. So what is this stuff beneath our feet? And most of us think of it as it's a mix of these mineral materials, sand, silt, and clay. And you guys, a lot of you in the audience, will be very familiar with that clay, those clay-sized particles, which is so important in an agricultural context for holding on to nutrients, releasing nutrients, for storing water, adding water storage capacity to soils. And then, as we get into larger particles, the silts and the clays. Silts and sand, sorry. But it's also got that life, which I mentioned earlier, which is so important for functioning, again, for the cycling of nutrients, particularly things like nitrogen cycles are so tied up with the biology of the soil. And that's why we often call it the kind of living skin of the earth, is a nice way of thinking about it, I think. So it's not just this inert mix of minerals. It's got water in it, and there's that field very close by to the one I was in a couple of weeks ago, with some water, which of course the life needs the water. If we don't have the water, then not a lot can live in the soil. And then we also have air as well, which is another component. And when I do this kind of thing with my first year students, which I'll be doing in a couple of weeks, or next week actually, that this is the one they always forget about, is air. And if you take a slice through a soil aggregate, which this is like a microscope slide with some soil mounted on it. We've taken a slice through, and you can see the pores running through it. Now, some of the times they'll have water in them, but hopefully some of the time they'll have air in them as well. And this is an example, and it's probably about 1 millimeter or so across. But what you can also see there, which is really interesting, is that the clay has been washed down through this pore, and it's actually been deposited on the side there. So that's just a little aside, and soil scientists get excited when we see these kind of things. But what about beneath our feet? And Claire asked me to talk a little bit about topsoil and subsoil. And what is topsoil and what is subsoil? Well, topsoil we tend to think of, I suppose, as this kind of organic material that's the living stuff on the top. So it's usually darker, it's usually got roots in it, it's got life and fungi and bacteria doing their stuff in it. And then as we go deeper, we get the subsoil. Well, often people think, well, that's just, clay or something, a bit of rock underneath. But actually, subsoil has also got a great deal of variety to it. And, I've just picked out 4 of my kind of soil profile pictures here. We've got one here with a stunning white horizon and then this beautiful orange horizon. Well, this is all subsoil, but it's all very different material, very different colour. This one's got looks like possibly old buried soils underneath it. This one's again a bit orangey, perhaps in the base there. So subsoil isn't just one thing. It's a variety of materials, and it has what as soil scientists we would describe as horizons. So these are, you could call them layers if you want, but say we would often describe those as horizon. This soil, they all have names as well, soils, and this one would be a podzol, which is one of my favourite soils. They're also very different in depth and characteristics, and so I just picked out 3 here again. So on the your far left here, we've got a soil which is rich in sodium, a sodic soil, not great for agriculture, but has this kind of white colour, and it forms particular columnar shapes in the soil when it dries. Here we're in Bedfordshire with a very deep soil. You can see the A horizon at the top there, but actually the subsoil goes down and just keeps going. And then there's a question of when does it become the rock and when is it the soil? And that's, we could probably spend several hours discussing that in that hole. And then here we are in Portugal, and soil here, the subsoil tells a kind of we've got the blackout moment. Is it going to come? Yay, there we go. And this soil sort of tells us historical story beneath an archaeological site, where we've got different layers which have built up over time, preserving past stories and of what people have been up to there. And then the final kind of subsoil picture is just to say that there is a rich variety, even within a very short space. So this was on my summer holidays this year in Dorset, and I was walking down a lane and where it clearly been recently kind of excavated on the sides, and within about 15 metres I had 4 different soil profiles. I had a very shallow one, which is over here. I had something deeper, possibly with a buried soil underneath it, some kind of fill material, so again a deeper soil, and then another shallow rocky soil. So you get, it's variable stuff. In agricultural fields, often that variability has been knocked out of it by ploughing and agricultural activities, but in the natural environment you often find soils that change quite rapidly over short distances. Oh, wrong way. Go this way. Okay, so just thinking then a little bit about clay and clay-rich subsoils, because I thought today would be a day to talk about clay, and there is a UK soil observatory viewer, which is actually quite a complicated thing to use. It's not that complicated, but it's not the easiest piece of software to use. But it's online. You can find it if you just search UKSO, and it gives you loads of soil information. But there is a really interesting map of subsoils, and if we zoom in on Stoke, you'll kind of get the feel for that around Stoke, to the north of Stoke, there was quite a lot of clay-rich material in that subsoil, and I like to think maybe early people were walking through Stoke thinking maybe they could make some pots out of that subsoil. I don't know. Perhaps they did. But any of you that are from this area might recognise these soils as being classified by having these very clay-rich subsoils and being very prone to waterlogging, which is why we see a lot of if you go outside Stoke to the north, you'll see lots of grazing land, but you won't see a lot of arable agriculture because they're just too wet to work with. And so these are, just some of the local soils that we have in this area. Okay, so I'm going to shift now to talk a little bit more about the effect that development has on soils and some of the work that we've been doing to try and offset it. So, one of we heard earlier about the amount of material that's stripped from sites, but we also have issues with on-site damage of soils as well. So you can imagine if you're driving heavy machinery around a site, you're going to be squashing that soil up, and as you squash it, it stores less water, and it infiltrates less water. So these, the compaction of soils on sites is a major problem, and it's very difficult to reverse. Even in an agricultural context, if we compact soils, it's a hard thing to recover them after they've been compacted. And we've heard about this already this morning, which is great, and it's great to see that people are aware of this, and to see. I was even more shocked by the numbers that Claire had, which are a bit more recent than mine. But this was kind of what got me into this area. I'm an agricultural soil scientist. I've worked on soil erosion and soil degradation. And then I saw this number. We had a PhD student working on urban soils. And she discovered this number of how much material was being chucked in landfill sites. And we just was kind of like bowled over, and we kind of felt we had to try and do something about it. And, it's 10 times more than we think is being washed off agricultural fields in the UK due to soil erosion. So it is, and that's my number, not Claire's number. So her number would suggest it's 20 times more than has been washed off. So we started something called the Soils in Planning and Construction Task Force with colleague Jess Davis at Lancaster and colleagues from the planning department in Lancaster and Cornwall City Council, and then some master planners and some landscape architects, and then we got some people from the construction industry involved and some people from the waste recycling industry, and really as a way of just sharing information and sharing ideas between us. And we have basically created this, I suppose, we call it cross-sector voice, and it's about trying to raise the awareness of soil in the construction industry. And we've published, I think, a couple of reports. One which is around about trying to have some thought about soil when you're doing construction projects, and then also another report about using for the potential of soil reuse and storage systems in the UK. So these are all available on our website, which is soiltaskforce.com, and please do join and do spread the information widely. And one of the other activities that kind of came out of that was working with local planners to try and develop local planning policy for sustainable soils. So, if you're a constructor, if you want to develop a site, you need to put in planning permission, and you need to look at the local plan, and you need to follow the guidance that's in that. So we were trying to influence that, and we worked very closely with, again, Cornwall County Council and Lancaster City Council on this. And they were both deeply involved, and we ran, hang on a minute, we ran a series of workshops and stuff with people to come up with some guidance on what could be in these plans. And so the idea was to provide kind of template text that could then be given to other councils to then incorporate into their local plans as well. And so this contains a focused soil management policy and then links to other areas of local plans that relate to soils. And the kind of principles of the model soils policy, they kind of echo the kind of principles of circularity in some ways, in that we, first of all, want to minimize any adverse effects. So if you don't need to drive the big vehicles over that part of the construction site, then don't do it and plan not to do it. If you can store the soil that you strip on that site on the site and then reuse it on the site, try and do that. So it's all about trying to encourage good soil management and not letting the soil go off site, because as soon as it goes off site, you then enter a kind of a legislative kind of minefield as to whether that soil is a waste or not. And so keeping it on site and keeping it within people's businesses is really, really important. And, the final point is about having a soil management plan and strategy for that material at the outset. So it's, about careful planning. And there's some really good examples of this that colleagues from the consulting industry have done, particularly around Cornwall, where they're producing, they've got a garden village they're producing at the moment. And there's some really nice examples of having soil management plans where they're taking soil experts to advise them on what to do. And then soil also has links to other areas of planning. I've talked a little bit about water already, and you can see the flood running down with lots of brown soil in it in that picture. So there's clear links there. There's links to the protection of the natural environment. And this is an example from Cheshire, where until the summer there was a planning application open to develop this area, which doesn't look particularly wildlife rich, but it's actually a lowland peat bog. And so you can imagine the amount of carbon and such like, and if all the creatures that were going to be taken out of that area had that gone across. It's now been withdrawn, thankfully. And then, of course, because soil stores so much carbon, there's really strong links into carbon storage and net zero. So it's soil. We've tried to produce text that people can embed into these other areas of their local plans as well. Great. So that's kind of, dealing with the planning. And I'd just like you to kind of, I suppose, to take away that soils do have value. Not all soils are alike. The loss of this material to landfill is an absolute scandal, and it's great to hear that so many people are thinking about it and thinking of innovative and interesting solutions as to what we can do for it. And I would ask you to be a soil advocate, to kind of share the planning guidance with your local councillors, and when you're building your slab ceramics, those of you who are builders, to think about the strong links between soils and ceramics. Okay, thank you very much.